Hi, Andrea.
Hi,
Good
Massimo.
morning. Good morning to everyone.
Morning. Thank you for your participation. For today's webinar, we are waiting another few seconds and people are connecting, and then we start with the presentation. We have just one information for you. Use your Q&A button if you want to make any question to us. We try to answer during this webinar. Or maybe if it's a complicated answer, maybe required further assistance, maybe we'll answer by email. Anyhow, you can contact us anytime, so you can send us an email and with your question regarding. Today is dedicated for, say, ESD and fire and gas application, so I would say SIL, functional safety application. Of course, we have other questions that that came from you during registration when you apply for this webinar. And those are strictly, there are a few questions dedicated to the SIL and we answer. Other are dedicated for IS application that is not specifically scope of today. So we'll please send us an email to tech@geminternational.com. We answer for our technical experts.
Yes, Andrea, today's topic wants to give an overview on how smart relays act in the most common ESD and fire and gas application.
Right.
And how these relays give us the possibility to extend the diagnostic functionalities of the safety system or PLC along the whole loop.
Okay, great. So then we start with a short presentation of GMI. So hope you can see. Speaker of today, myself, Andrea Spaloro. I'm a global account manager in National. I'm following the main automation contractor, and I was responsible for European market, and now more to the key accounts management. There is Massimo Pagani with me. Massimo Pagani is our technical expert. Maybe he's the one that he answered to your question. If you send an email to us. Massimo has a very long experience. It's just back from Middle East. It's supporting our customers in a big application, refinery application. So he knows almost everything. Maybe it's too dangerous for you, Massimo, but almost everything about our products. So he's very good in skilled in the technical aspects. And our company, we are GM International. We produce physically safe and SIL certified devices for main applications. We have a very long experience in this market. Before with Econ, under the Econ Instruments name, now GM International. We produce completely in our facility in Milan, but here we have also global presence in 5 continents. Continents are everywhere, so from Mexico, US, France, Italy, and Middle East, in Dubai, we have in India, we have in Japan, in China, and Singapore. We work also through distributors, so you can find other people that can help you locally in all countries. And we also organize different cybersecurity, functional safety, EX courses per year beside the webinar. So this is another aspect, functional safety with exam, with a diploma at the end. And of course, this is a very important part for Germany. Few words, we produce very complete traceability for incoming components and the PCB and outgoing products finalized. So every single unit is tested 100%. We provide 5 years warranty on all our products, and also we grant availability when the product is in the phase out. There is a strict, let's say, policy for having the product from availability available to phase out to spare parts only and to discontinue. So, but we when this process started from available to phase out, it will take another 10 years, and during these 10 years, we grant the availability for the products. We have also complete certification for all markets, or almost all, of course, that cannot be always completed, but we have a complete, let's say, certification for the most important PX markets all over the world, and also maritime application directive. Products we produce in intrinsic safe barriers, safety relays. This is a safety relays, the most important part for today. Isolators, safety power supplies, multiplexer, termination boards for all DCS and PLC, HART, multiplexer, surge protection indicators, and the last bullet is regarding the courses that we organize all over the world. Some customers divide by system vendors, EPC, OEM, and users. Okay, I don't want to take more your time on this aspect. We go directly to the today's topic, so is safety, and we're gonna talk about this divided chapter, and so safety, relay concept, firing gas applications, ESD application, Modbus, and the conclusion. If you have any questions, just write us on the Q&A, and we answer during the, say, maybe the slides explanation. So, Massimo, I think is mine yours?
Yes, thank you, Andrea. And let's start with our webinar, examining those that are a fundamental part of a SIS. Let's talk about the safety relays. Safety relays can stop or initiate a movement in a controlled, safe manner by opening or closing valves, start-stop motors, and so on. And they must conform and adhere to the ESC 61500 and the industrial standard. But not only in oil and gas or process industry, but in general, a safety relay can be used where a failure of a relay can cause serious accident to human, environment, asset, or image. So, but what are the typical cases where a safety relay is required? Well, typically, we must use a safety relay in all those applications where the controller, our digital output card of a PLC, for example, is unable to activate a field device due to its limited potential in relation to the voltage and current involved. Or in those applications where multiple contacts for the simultaneous activation of multiple laws is required. Or again, in those applications where the safety function that the controller must perform needs to be inverted. But what is different from a standard to a safety relay, and why a standard relay cannot be used in a SIF? I leave Andrea to explain this point.
Okay, so we're gonna say that, of course, a relay is standard relay cannot be used in a SIF because there is a safety relay is an hardware with no guarantee availability to perform a given safety function. So a standard relay has not a non-guarantee ability to perform it. So it's a standard product. So the goal, the target, or the application is to reach a safety state on demand. So basically, you want to open or close a valve or activate a fire extinguisher system. So this is the main application. So it's a open, close, or start and stop. Those are the applications, but it must be reached, of course, with a certain security. We would say that the application must be, or the safety function must be reached at a very high percentage. The typical application is ESD, EFC, so it's a part for today, HIPS, or BMS, where the normally energized application is required. So the safety function is de-energize to safety. So from close, you want to open. That is the application for those. Of course, in the firing gas, the function is the opposite. So you are de-energized, you want to energize to safety. ETS is called energize to safety application. And this you can see here, basically, the picture. You can see that this relay, that is our hardware, on the top is de-energized because there are 3 relays in series. So just one open and the loop is open. Why on the bottom, the 3 relays are connecting parallel. In this case, you see the parallel connection. Sorry. Yeah, so this is the parallel connection. And in this case, if you want to energize to safety, just one has to be closed for safety reasons, of course. All 3 close, but just one can close and the loop, your loop is on. Okay, Massimo, you again.
Okay, well, but in the category of safety relay, we also have the smart relay. Well, before going into the specific of how a smart relay works, let's see what a smart relay is. The smart relay is a device that guarantees a specific safety function, like a typically safety relay. But in addition to the safety relay, it has the ability to perform a complete field diagnostics. For complete diagnostic, we mean a diagnostic that includes complete constantly monitor of line and load function in both operating conditions of the relay, on and off status. In fact, the diagnostic of a smart relay is able to monitor the functional parameters of the field device and the line to know in real time the health status of the loop in the condition of load energization, and as a predictive function to know whether in the event of a request for intervention, the devices in the field will activate correctly. This is a very important, especially for in fire and gas safety system. We can say that smart relay combine the basic functionality of safety relay with a complete line and load diagnostic. But why going for a smart relay? Well, nowadays, full diagnostic is typically required along the full loop. However, many widespread systems do not support diagnostic inside their digital output cards, or smart relay make diagnostic available to systems that do not support it. In other cases, many modern systems do support digital output diagnostic. However, in many applications, they cannot directly drive the load because they are voltage and current limited, typically no more than 500 milliamp at 24 volt DC. Or when the load, valve, beacon, sounder, and so on, require more than 24 volt and or more than 500 milliamp. Relay, in this case, are necessary. Yet, when uses standard relay, the digital output diagnostics dies at the relay coils and cannot reach the load in the field. As opposed to that, smart relay can go beyond the typical voltage current system limitation while keeping the full load diagnostics. Even if modern system can perform load diagnostic, their capability may be limited. For instance, air leakage monitor may not be supported, or extreme load, for example, beacons, may always be reported as an open circuit to the system. Smart relay may offer a solution to extend the digital output diagnostic capability. Well, in the next slide, we see that two different safety functions coexist inside smart relays. The first and also the main function consists in the input to output or coil to contact activation deactivation. This is the typical function of a safety relay, which upon request is able to drive a load applied to it in a safe state. The second one is the diagnostic function. It provides full measures, voltage, current, resistance, or leakage in some cases, of the load, also through Modbus protocol, and it can activate or deactivate two fault dry contacts. The smart relay is typically equipped with the full relay, and any anomalies can be acquired through the Modbus protocol. Also, the smart relay is available for installation in a hazardous area, to be precise, in Zone 2, Division 2. And we can say that the main function, coil to contact, is certified SIL3, while the diagnostic is certified SIL2. Well, Andrea, I think we have the first poll for our attendee now.
Okay, just to keep you awake, of course, we have a first poll just to know what relay and maybe application you do on your safety. If you want to answer, very simple. So what relay type do you use on your safety application? Common relays, no safety, standard relays, safety relay with diagnostic functionality, or maybe the PLC that integrates relay functionalities. So there are, of course, the world is so wide and so many different manufacturers offer different capability, and also for the relays. So if you want to answer, just to maybe we can have an idea about your word, of course. Thank you for answering. We're gonna stop in 1 second. Okay, no few. Okay, no more. Thank you. So we see that just to share with you, of course, you see that most of you use a safety relay diagnostic functionality, which is the topic today. Standard relays, of course. In many applications, we see in especially for DCS application, many DCS don't have the line monitoring functionality, so also the standard relays can be used for those applications. But that basically for safety, the diagnostic functionality are more and more required. Okay, thank you. We're gonna show you the next. So what is? So what is a specialty for GMI is the matrix relays. So we have found that this typical application where we have 4 relays connecting this kind of matrix, we call it matrix, we are two in parallel and connecting series and other two in parallel, are really a universal solution for normally energized and normally de-energized loads for all applications. So this increase the availability and the fault tolerance. And also can be used for bipolar isolation when for safety, for operator safety, in case you wanna have, say, this disconnection from both sides of the load. What is very important is that you see that maybe in this case all relays are closed. You want to open. You see that one is stuck. Do not open. But you see that the circuitry here is open. Let me show you the highlight. Is open here. That is very safe. So one relay is not sufficient for causing the failure of the safety function. And also in case, the system is not requiring a safety function, but one relay is failing and maybe is open or closing, also in this case, this is not sufficient for or causing a fault. This is called availability. So this kind of metrics, relay metrics, which is available on part, not all, of course, our relays, grant high safety and high availability at the same time. Other features is the pass testing capability. So the pass testing, main PLC and the DCS digital output card are generating this kind of testing, can be on or off in all time, during all time, just for testing the relay connected. And of course, this, as long as there is not, say, electrical connection between input and output of the interface, this basically is not be transmitted over the relays. Okay, so you cannot check your load over the relays in this case. But it's very important that the hardware you're using must be, of course, compatible with this pass testing, and this compatibility is, of course, is proven by, of course, the long last of our relays. So they are fully, there is a circuit inside that filter completed the pass test. It's not damaging the relay, and otherwise you can have a flickering, continuous flickering of the relay, and by the time you get damage the hardware you're using. Okay, so now we have the last one from my part.
Yes, Andrea.
Yours?
Let's see now specifically how the relay, the safety relay, or the specific case, the smart relay can communicate with the system, with our safety system, our PLC. Smart relay can report the field status to the system in several ways, as we can see, and we can say before, we have two fault codes that can be acquired by a system digital input card. This is the typical way, which implies the use of a DCS with a dedicated digital input card, where the status of contacts called a fault is monitored by the system. The second method, if the system digital output card that driving the smart relay support path testing, the fault in the field can even be mirrored directly to the digital output card of the PLC without the need of an additional digital input card. Complete diagnostic information can be also retrieved through Modbus multi-drop RS485 protocol if a Modbus master is available on the system side. I want to remember that through the Modbus protocol, the relay can be also constantly monitored and configured remotely. And again, the fault on bus can also be acquired by a system digital input card. The fault on bus is normally used when a cumulative effort from many modules is required. Well, Andrea, I leave you to explain the next part.
So related to the full diagnostic, just to resume, the SIL3 are SIL3 certified. There are a few types for using for D1596S and D1596S-100, D5294S are used for fire and gas application, very high, normally high availability, while the 1597, D1597S, D5295S can use for fire and gas application, normally energize high availability, phase inversion. There is a complete load and line internal diagnostic, so we can monitor voltage, current on load, the load resistance, the leakage from load hurt, the coil integrity. Coil integrity is the healthy of the single relays inside, and internal faults. And also, Modbus is supported not by all, but from a part of these relays. There are, of course, alarm available is through 2 fault relays, through bus, through Modbus. Very important is compatibility, as we say, with the pass testing and the fault mirroring on the OCAR. So for the PLC that support the line monitor, the pass testing, the fault can be transmitted directly on your DO without using digital input on your PLC for acquiring the fault. Contact rate is 4 amps, 6 amp in rush, installation for zone 2, universal mounting, and isolation between input, output, and power supply system. Here, resume of what the relays can offer. So these are the main. So you can see that can be the monitoring is available for voltage, current, load resistance on all the relays, while the 252D, 5294S, 5295S can offer also the load to earth leakage and internal coil integrity monitoring. So the relays inside can be monitored only by these two relays. Okay, then we have now the second chapter, the real application for fire and gas. So we can go on with Massimo.
Okay, Andrea, thank you. Let's introduce the specific topic of today. Typically in today's process industry, there are different types of application. Of course, one of the most important is certainly the fire and gas system. But what is a fire and gas system, and what are the tools that GMI offer to meet the needs of this type of application? Well, a fire and gas system continuously monitors for abnormal situations such as fire or combustible of toxic gas released within the plant, and provides early warning and mitigation action to prevent escalation of the incident and protect the process or environment. In most cases, a fire and gas system involves the activation of a load, such as the latch valve, other signaling tools such as bells, sounders, and beacons, or a ventilation system, and so on. Of course, the brain and the controller of the system is the safety PLC. But to make a plant or the entire industrial process safe, it must use smart tools as a smart relay. Because they are called smart relay, because this relay allows the PLC to extend its diagnostic capabilities up to the final load, which in the fire and gas system is that element that is activated to protect the system or to give the alarm signal. And why is it important in a fire and gas system to always be in control and always know what is the state of health of the system? Well, the answer is what will happen if at the beginning of a fire, the fire and gas system is not available due to its own failure to intervene to mitigate the damage. We will have disastrous consequences. But let's see how a smart relay can help us and how it works in a fire and gas application. First of all, we can say that internally, a GMI smart relay is composed of a matrix of content, as Andrea showed us in the previous slide, which allow us to have higher reliability and high availability to the process. This safety relay is in fact SIL3 certified, both for application with normally de-energized loads, our fire and gas system to be clear, and for application with normally energized load, ESD type application, which we'll see later in this presentation. But let's see it specifically. The load applied to the relay, in this case a beacon, is off in a normal condition, and the relay contacts are open. When at the request of the safety PLC, the load must intervene to signal the dangerous event. The relay closes its contacts. Through them, it supplies power to the beacon, which gives the alarms. A typically fire and gas application involving GMI's D5294S MAR relay is the following. The D5294S monitors the line, the power supply and the load, in this case sounder. Next slide, Andrea, please. Under normal condition, for example, when switched off. By doing so, it ensures that if requested by the PLC, the loop will work correctly. This type of relay can be configured via software or via Modbus for specific diagnostic volume. When switched off, it's able to monitor the impedance of the load, the power supply to the load, and is able to auto-check the coil of its internal electromechanical relays. It's also able to provide two-fault contacts towards the DCS system dedicated to the purpose, or it has the possibility of mirroring any fault detected in the field directly on the diagnosis PLC card. This function, called for mirroring, is compatible with different types of the digital output cards of the most common PLC system and allows considerable saving in terms of engineering cost, as it allows the non-use of a DCS system dedicated to acquisition of the fault. Let's see how it works. The relay monitors the loop, and if it's detected a malfunctioning of the load or its power supply, it immediately reports it to the PLC through the mirroring function, or to a dedicated DCS system by closing two fault contacts. This is called predictive diagnostics, fundamental in fire and gas system, to ensure that the loop will work when there is a real need. The smart relay, in this case, through its diagnostic function, allows the PLCs to extend its loop monitoring capabilities up to the load. For this reason and many others, the smart relay is a fundamental tool in fire and gas loop. Furthermore, this type of relay can communicate and can be programmed via Modbus, with all the advantages that this communication protocol can give. In the next slide, we introduce what is the relay programming software, which allows us to have total control over the function parameters of the load and the voltage applied to it. As previously said, in condition of relay off, it can monitor the impedance of the load, the power supply voltage of the latter, and the health of the internal electromechanical relay. This relay also allows us to set the windows of values within which the diagnosed variables must fall in order not to generate a fault. In fact, for example, we can set a minimum and maximum value for the load power supply, outside of which the relay will signal an anomaly to the system. The typical example may be that represented by the short circuit on our load, caused by a malfunction of the winding inside the beacon. The relay, by monitoring the impedance of the beacon's input circuit, will read an anomalous value outside the window of value considered valid during relay programming, and will signal a fault to the system. This fault signal will occur through the closure of the two fault contacts to be acquired through a dedicated DCS system. A red LED will light up on the front of the relay. And again, in the next slide, through the programming software, it's also possible to monitor in real time what's happening to the loop. Any fault will be underlined by a red indication and will warn us that the mirrored value have gone out of normal operational activity. Also, the D5294S is able to detect the air leakage of the load and report this anomaly in the ways already seen previously. Through the software, it's possible to set a leakage resistant value below which the fault is detected. Also, in this case, the configuration software provides us with important information on the state of health of the load, monitoring the impedance value that the load has towards the ground. In this case of fault detected, the relay communicates the fault occurred to the system to allow us to act promptly on the problem and solve it. We have another models of smart relay, D5295S. This particular smart relay acts when some old PLC systems work with inverted logic, always supply energization to the relay. For this reason, we need a relay that reverse the safety function of the SIS to bring our fire and gas system to safety. Also in this case, the GMI Smart Relay help us by giving complete diagnostic coverage to the loop and helping the PLC to reverse the safety function. In this case, the D5295S model maintains the function of the models present previously and changed, but give us the possibility of interventing the safety function using normally close contacts. In fact, under normal operation condition, the load will be normally energized. Therefore, for a fire and gas load, the PLC system must have a normally energized logic so that the relay can reverse the function of the load. In this way, the relay contacts will be open during normal loop activity, and at the request of the PLC, the relay will be de-energized and the contacts will close energizing the load, which will provide the alarm signal. Also, for this type of relay, thanks to the contact matrix technique, we'll obtain high process availability and high level of safety SIL3 certified. Also, we can say that for this smart relay, the diagnostic function remain unchanged. In fact, with a view to predictive diagnostic, will we be able to monitor in the state of the load and its supply voltage when the relay is energized. That is, when its contacts are open and consequently the load de-energized. In this way, we will be able to monitor the impedance value of the load to verify its state of health over time. In case of anomalous variation of the load input circuit, the relay will signal the change to safety system declaring a fault. Andrea, okay, thank you. Fault which, as we have seen previously, can be signaled in the different ways through the mirroring function, through the fault contact to be dedicated to a specific acquisition system, or even through Modbus. Well, the types of relays seen up to now for fire and gas application are also widely used for emergency shutdown application. In fact, thanks to the contact metrics, these relays are able to perform a certified SIL3 safety level and high process availability even for this type of application. But how does a relay work in an emergency shutdown application? Well, the relay in this case is the device which, at the request of the safety PLC, must ensure the de-energization of its load and bring it to a safe state. Typically, we are talking about a shutdown valve, which must interrupt the flow of dangerous fluid to bring the system to safety. In this case, we are talking about an application that involves a typically energized relay, which in turn works in a normal condition with its contact closed and energize the shutdown valve, which in turn allows the pass of the dangerous fluid. Also in this case, the use of a smart relay, it's important to monitor the health of the valve. It's necessary to know in advance any problem that could arise in the event of a request from the safety system if the valve should have any problem. The smart relay guarantees complete diagnostic of the load and of the line associated with it, even in the condition of energized relay. In this condition, the smart relay constantly monitors the power supply voltage of the valve and the current that circulates in the coil of the later. In this way, it's possible to monitor every slightest variation in the state of the relay loop. And also in this case, the smart relay helps and extend the diagnostic capability even for normally energized load. Thanks to the contact matrix, the D5294S smart relay provides high availability to the process. In fact, the failure of one of the contacts inside the matrix is not sufficient to generate a malfunction of the relay, which maintains its function and changes also for this eventuality. Even for this type of application, the configuration software signals any load malfunction by reading the variables related to the load itself. The signaling takes place on the monitor, underlying the cause of the fault in red or with the types of communication seen previously. Another particular application involving smart relay with normally energized load is that related to the valves with dual coil. In this specific case, since each coil is sufficient to activate the valve, the two coils avoid false intervention in the event of a single coil opening, thus increasing availability. In this context, the D5294S can detect the opening of the single valve coil. Through the configuration software and by specifically setting the diagnostic value of the current flowing in the two coils, it's possible for the smart relay to detect if one of the two coils is interrupted. In fact, if one of the two coils is interrupted, the current circulating in the loop is halved and the value read by the relay leaves the window of the set value, signaling a fault. Fault that also in this case can be signaled to the safety system in different ways. One of these is the mirroring of the fault, which communicate the problem with the load directly to the digital output of the safety system through a variation in the impedance of the input circuit of the smart relay. This functionality has been tested with some of the most popular safety PLC on the market and found to be fully compatible. Well, Andrea, I leave you time for some words on Modbus and compatibility with
Thank you,
our devices.
Thank you. Just a few words. You see, we have seen this kind of relays that are the only ones that can be configured. So the setting, the threshold can be configured over software, and So there are most of the time, say, field devices that have specific values for resistance, current, voltage, earth, whatever. And in most of the time, or maybe some cases, you need to set this value to be considered as alarm. So, and other relays also we are offering other type of solution that, and also our competitors, the market offer a solution that have not this capability, so they are not configurable. The threshold cannot be configured, and in this case, this solution offer really, say, flexibility, and otherwise maybe you get alarm continuously while you are not in alarm condition. So this is a solution. Okay, thank you. So we have hope you are still there. Maybe no question from you, but maybe we have a question to you. With another poll. We wanna launch this poll. What safety feature do you consider as relevant? So we have shown a lot of things so far, like past test compatibility, if you consider relevant, as alarm contact out. You have seen that the alarm can be transferred over contact or can be transferred over fault mirroring, so directly on your DO. Or maybe you want to have the Modbus output, or you prefer, as explained, the configurable threshold. Thank you for your answer. Maybe a few seconds. Maybe you can, I think you can decide more aspect, more answer, so you can have a different, say, preferences. Okay, others? I see you are answering, but not all. You can wait another few seconds, otherwise it takes too long. Okay, I'm gonna stop it in 1, 2, 3, 4 seconds. Okay, great, thank you. We want to share with you also so some of you choose alarm content, default mirror, Modbus out, and the threshold, and not really important. Okay, thank you. Thank you. We're gonna continue this presentation, and okay, the last important for today is the Modbus interface. We've seen that some of our relays offer the Modbus capability, and this is a real Modbus device, so you can connect all relays in a single line, a single Modbus connection via multi-drop. They can connect all together and connect to a Modbus master. The PLC can be Modbus master most of the time, have this capability. What is the importance of having this kind of features? You have one relay, one Modbus interface for all relays connected. You have this multi-drop connection, and the connection can be extended up to 1200 meters, so a lot. You don't need digital input for alarm monitoring, because you have everything through Modbus. And also, maybe the most important thing is you get full information about your relays, about your loads. So you, if you have, just to give you an idea, if you have, if you use a mirroring, or if you use a contact, you just know that there is a fault, but you know what kind of fault you are experiencing at that time. While with the Modbus, you can have different registers that can be associated with different information regarding it. You can know if it's a problem with the relays, or the load, the power, the leakage, whatever it is, you can get through Modbus, and everything in one say screen. These are the features. Of course, you need to use some relays that offer the Modbus interface, which is not available on all, and you need to have your Modbus interface on your PLCs. Okay, let me get to the conclusion of the question from you. I'm a little bit afraid about that, but anyhow, hope you appreciate that. conclusion are this. So we want to say that compatibility for the safety rule with most systems used for safety applications was Schneider Electric, Yokogawa, Schneider Electric, Tricon, Tricon CX, Foxball CS, Modicon, M5 and ATS, ProSafe from Yokogawa or Cento VP, Honeywell Safety Manager, Russo CIO, Safety Manager C, also the latest one, Expiron from Honeywell, Emerson Delta V SIS, ABB ACE800, IMAX, Rockwell Hardbacks. We have a long experience. We test with every single manufacturer. We still continue testing because, of course, they are moving, they are releasing new hardware, and we want to be up to date on this hardware. So if you want to have more details about that, I invite you to contact us, contact our technical support that will provide you the right answer, maybe the right also test report regarding the different relays or barriers also with different manufacturers. So we are at the end, Massimo. So yes, just for give you full overview and then we stop it.
Yes, we try to summarize what we have discussed in today's presentation and why it's important to you. The first point is the universal solution, which allows us to extend the limits of the system digital output card for the compatibility of all the loads applied to it and in all conditions.
We have a diagnostic level very important, so we can monitoring open short circuit. Those are the main, of course, but also the power supply for your load in case of fault, ground leakage, load resistance variation, and internal relay of the interface fail.
Yes, the third point, high process availability and fault tolerance for the prevention of spurious trip with the contact matrix, GMI Smart Relay, which allows more resilient solution that prevent the system from downtime.
SIL3 certification, and which is SIL3 availability. SIL3 certification available for, depending on relays, but for 5, 6, up to 8 years SIL3. So then you need, you know, you recertify, you recheck the, no, rechecking the status, the health of the relays. But the lifetime for this relay is 20 years, which is very long, compatible with the PLC lifetime.
Yes, we also discuss with the transparency of the field fault through the mirroring functionality of our smart relay, allow significant saving in terms of installation and wiring cost.
Cost reduction. So the mirroring or the Modbus reduced the need of having digital input card dedicated for faults, reducing the hardware, wiring, and simplifying the engineering.
And again, a great flexibility with GMI solution, which allow us to manage all types of load and field condition in small spaces.
The Modbus interface already say that it improves the troubleshooting and continuous data acquisition.
And again, the possibility with our relays and smart relays in some cases to manage types of loads connected both in unipolar and bipolar way, guaranteeing field diagnostics where required. This solution allows great saving in terms of installation cost.
Through track record, so we can grant really long experience and continued experience on new hardware, new solution that, and also certification, test, and reference that is the base of our offer. So we remind you that thank you for attending here. We remind you that there is a webinar schedule on our website. You can see all the next webinars through this dedicated page or through LinkedIn. If you are connected to GMI, I invite you to be connected to GMI. We want to just get your, let's say, opinion on this webinar. So it's very important for us. Maybe we can improve. Of course, we can improve always, but hopefully it was interesting for you. I invite you to send us more questions by email, or you can contact us anytime. So we are on LinkedIn. We are, of course, available. And as I said, we have documents that can give you more idea how to connect, what feature you can use on relays, how you manage the application. It's very, the world is very, let's say, different. And so in the different part of the world for different manufacturers. So we have these documents available. Okay, thank you for your votes. Thank you. I'm gonna stop it. Everything is good, so I'm gonna stop it now until I get bad votes. Thank you. And we are really at the end, just to remembering our name, our emails, and our faces, so you can contact anytime. Thank you very much.
Thank you very much, Andrea, and thank you all our attendees.